right, here we go. Good morning, everyone. While we wait for folks to get in here on this cold Missouri morning, finally. Let's see, I've got folks coming in. Dana, Bridgette, Joe, you can see the screen, right? Perfect. Give folks just a few minutes to get in here and then we'll get started. While you're gathering, just remind you that we are in webinar mode, and so it's not as interactive as a Zoom meeting, but we want it to be as interactive as possible, and so you have opportunities to both chat, but also ask Q&A in the question and answer section. And we want you to ask those questions throughout. We have three great panelists this morning, and they're each going to present, and then we'll do the Q&A afterwards. So if there's a question you think about while they're speaking, go ahead and type it in, and then I'll ask those questions when we get to the end of the presentation. If we don't get to all of your questions, my email address is on the bottom screen there, and you can email me for any follow-up. And as always with our webinars, we are recording these, and they will be put on our YouTube page afterwards. We've got a library. It's weird to think that we've been doing these webinars since 2020. We started these during COVID. So we have 5 years of webinars now in our YouTube library. So please take advantage of those. Lots of great topics. All right, well, we are going to go ahead and get started. And welcome to everybody for the Historic Preservation Deep Dive, From Action to Funding, How to Keep Your Historic Property Vibrant and Occupied. Thank you for being with us here today. And for those of you watching us later on YouTube, welcome. We have some great panelists with us today, and I'm going to talk about those folks in just a second. But just like your Main Street programs, we have committees within our organization. We're a nonprofit, just like the majority of our Main Street programs in Missouri. And so we have a Historic Preservation Committee, and both Dana and Bridgette sit on that committee. And so they were part of helping plan this webinar, this deep dive webinar. We're going to be a little longer today instead of our normal 1 hour. So we're going to be able to dive a little deeper into those topics. And so both Bridgette and Dana are on that committee, and they're going to be part of this presentation today. And so we're going to start off with some introductions real quick, and then we'll move into that presentation. So Dana has been on our board of directors, I don't know how long, a number of years, and was on our outreach committee for a while too, and then moved over to the Historic Preservation Committee. She's a principal at SFS, which specializes in preservation, restoration, and rehabilitation of heritage properties. She collaborates with owners to preserve and adapt cultural significant buildings through thoughtful, research-driven solutions that balance historical integrity with contemporary use. Joe is new to our webinar family, and we're glad to have him here today. He joined KPF in 2014 and has 20 years experience in structural design for a wide range of project types, including historic preservation, which we're all here for today, residential, commercial facilities, and parking garages. He is skilled at managing projects and is responsible for all aspects of a construction project. I like this. When he's not working, Joe, of course, spends time with his family, but also renovating his circa 1890 Second Empire influenced home. And he also is a small batch winemaker using his own homegrown Chambourcin grapes. And then we have Bridgette, who has been on several of our webinars before. She was part of a national award-winning downtown Washington, Missouri. She's been doing revitalization for over 20 years, where she was the former executive director of Downtown Washington, Inc. She is the current executive director of East Central College Foundation. She is a member of our Missouri Main Street family. She was a founding member with Gayla Roten, our state director, and currently serves on our board as the vice president. She is a lover of history, chai tea lattes, and all things cats. So that's our panel today, and I'm looking forward to this great discussion. Normally Ben White would be the host for this webinar because he is the the staff person with the Historic Preservation Commission, but he's on vacation this week, so I'm subbing for him today. So I'm looking forward to learning all about historic preservation. So I'm going to turn it over to Dana and let her share her screen, and we will get going with the presentations.
Okay.
All right,
Am I
Dana,
good?
ready to go.
All right. Good morning, everyone. Um, well, I'm going to give a quick plug for our one-pagers, which I'm going to speak on, the Keeping Up Appearances one-pager that Ben so eloquently wrote and issued. I think it's been out for about a year. So what I'll be talking today about is routine maintenance. I will try to make it as exciting as I can, but really walking through your property and starting from the parking lot all the way inside the building, up into the attic, through the basement, the crawl spaces, and going through element by element, system by system of what you should look for and how often you should do these visual observations, inspections. And the purpose of a good maintenance plan is really to prolong the life of your building through routine maintenance. This is about routine maintenance and not deferring maintenance, which ultimately can end up resulting in a larger and potentially cost prohibitive project. So this is really about keeping up appearances of your building and ultimately maintaining a healthy main street.
Dana, I'm going to stop you for just a second. It seems like your volume went down. I don't know if the microphone got covered. I know you're using an owl.
Can you hear me better now if I get closer to the owl?
There we go. There we go. Perfect. Yeah, maybe
Okay.
it wasn't picking you up.
Okay, I'll do that.
Perfect.
Um, Thank you. I'm going to be showing some pretty gnarly looking, kind of worst case photographs, which is what we don't want to happen to your property. And I've zoomed in on these photographs and keeping the names of the buildings withheld to protect the innocent. So first off, starting with the site. Um, think about quarterly parking in the parking lot where your visitors or your patrons might park and walking from the parking lot to your front door. Um, as you're doing this quarterly, check the parking lots, the concrete curbs and walkways, the retaining walls. And what you're looking for are cracks in the asphalt, like you're seeing in the left and right hand photographs, spalls or missing pieces of concrete. Um, Also looking for displacement, any type of horizontal displacement of more than a quarter of a half an inch in a sidewalk can become a tripping hazard. So look for those types of deterioration and make note of it. And if they're in a bad condition, consider repairs. Also on your site, um, also seasonally, looking at your trees and your shrubs. Um, for your trees, you should consider pruning them annually, so that something like what's shown in the middle picture doesn't occur. And I'm going to admit that this is my house and this is what happened to one of my favorite 70-year-old trees in our front yard after a windstorm, and possibly if we would have reduced the amount of limbs, could have prevented this. So annual trimming, pruning to make a healthier tree um, would potentially have prevented this. And also fertilizing your bushes and trimming your bushes and your trees quarterly. Another important thing is to look at your site lighting, especially as the days are getting shorter. If you have patrons visiting your building, site lighting is really important for the safety of your visitors and patrons. One bulb that goes out, is not illuminating the sidewalk properly can also result in a hazard for your visitors. So inspecting your lamps, making sure that the bulbs have been replaced, can help with that. Also, site drainage is really important, especially this time of the year with the leaves and the debris. Checking your drains and making sure there's no leaves that have gotten into them, if there are, removing them. Um, these are things that should be done quarterly as well as after a storm. As we walk inside, our buildings, next go into those spaces that are the least occupied. So, going up into the attics, the basements, the crawl spaces. These are spaces that you're not often going into, and usually where water infiltration is going to occur first. At your foundation walls, quarterly, check for signs of moisture, inspect for cracks. Usually, like the photograph on the left, water is starting to come through the crack. That's a sign of water infiltration. Check for spalling, displacement of the foundation walls, as well as rising damp. So that's water coming from below and rising up into your foundation. For your crawl spaces, yes, it's important to get into your crawl spaces and also check for quarterly and check for water infiltration, as well as this seems to be where um, animals will come in. So check for any types of nest holes or animal droppings or decay quarterly as well. Foundations and slabs on grade. Another important thing to check quarterly, looking for cracks, chips, and uneven surfaces. This is not a haunted house photograph on the left. This is an actual um, uh, slab that's that's falling and resulting in some structural damage. Um, Areaways, the photograph on the right is an areaway. Looking at the airways and seeing that we've got water standing is not a good sign. Likely there's a drain that's clogged that needs to be unclogged, um, or somehow figure out a way to get the water out of the areaway. For um, uh, after you've gone to the basement, checked out the crawl spaces, then go up to your attic, or in the case of this photograph on the right, this is a church bell tower. Um, Again, spaces that you're not daily going in and out of. It's important to go into these spaces quarterly, um, and check your wood roof and floor framing and columns and beams. You want to make sure that this is not occurring. This is some heavy termite damage. If you see this, you're going to call Joe or another structural engineer. But going into these spaces at least annually is important. You're looking for water damage, decay of the wood, fastening failure, inspecting for any type of faulty connections, deflection, or as you know, in this case, termite damage, and then you probably want to call the experts in. We're calling this the superstructure. So outside of the kind of the foundation walls and slabs on grade, so this is the structure that's holding up the building. Um, Looking at, in this case, and a lot of your historic buildings might be constructed of concrete beam and slab construction. For concrete, look for cracks and spalling and water damage and deflection annually. Um, in the case of the image on the left, very shallow placed rebar with water infiltration, the rebar's rust jacking, and the concrete starting to fall. And then also in the case on the right, at the base of the column, same condition. In this case, we have rising damp and it's starting to rust jack the rebar and the concrete is falling. So this would be more of an annual inspection. For the building enclosure, so next go outside and look at the building enclosure or envelope. I usually recommend doing this after an interior inspection because typically what you're seeing in the attics and the foundations will often extend to what you see on the outside. So with the exterior, looking at the brick, the stone, um, concrete masonry units of the bearing walls, looking for cracks, spalling, missing mortar, which is the case in the image on the right. This was um, so this is the exterior brick on the outside of the wood beam that we saw in a previous photo that showed the termite damage and the water infiltration. And this is likely the reason for the water infiltration. And being that it was up on a bell tower, it wasn't easily seen until we got into a lift and visually observed all of these open joints, which were allowing water infiltration. Um, all of these items are things to look for quarterly or seasonally. Again, just on a routine basis of checking your brick, stone, mortar conditions for wood clapboard siding and trim, looking for rot or moisture damage or insect damage. Um, wood shingles, look for loose shingles or missing shingles as well as insect damage. And the same goes for your wood trim and wood windows and doors and porches and balconies, looking for moisture and insect damage and paint failure. Image on the left is showing some paint chipping, peeling of the wood trim, inspecting that and documenting the condition and repairing it too if it's exposing bare wood. Windowsills, checking for cracks. The middle photograph is a perfect example location of a location where water will infiltrate to the interior of the building. Also for wood windows, looking for cracked glass, rotted window sash and cords. And then for doors, looking at for example, the door on the right, the stained finish is deteriorating and repairing that. And then the hardware, making sure it's in operable condition. Also, it's a time to look at the storm screens and repair them or install them if they're the kind that you install seasonally. And you're probably sensing a theme, and that theme is water infiltration. So really what we're looking for throughout the building enclosure is where is water getting into the building and how to mitigate that. So also seasonally, check your roof. Make sure there's no pooling or ponding of water, such as what we're seeing in the image on the right. And if there is, often there's a roof drain that's clogged that needs to be cleaned out. At the same time as you're on the roof, sweep the roof of any debris. Um, check the type of metal roofing, and there's several different types that you likely have, whether it's metal or a composite, like an asphalt shingle roof or built-up roofing. Um, inspect the roofing for metal roofing, look for loose sheets or deformed sheets. For asphalt shingle roofing, look for loose shingles or curling or deterioration. And the membrane roof, look for cracks, holes, or tears. And again, all of this would be done seasonally, so or quarterly. This is one of the biggest locations where we see water infiltration is metal flashing, counter flashing at the back edges of parapet walls. And so when you're doing your visual inspection, look for conditions such as this, where the sealant has failed between the top of the metal flashing and the brick masonry. If you see this, automatically replace the caulk in the joint here. Also for metal flashings, just check to see if there's anything that's loose. Um, Gutters and downspouts. The image on the right is not what we want to see. This is clearly a clogged gutter and or clogged downspout, which is allowing water to rest in the downspout and then seep out onto the brick masonry behind. Um, this is something to be done quarterly, is cleaning out the downspouts and the gutters. Another thing that we see a lot is water coming from a downspout and letting out directly onto grade without a splash block. The image on the left really needs a splash block, or it needs to have the leader extended um, out into the grass. The image on the right is another thing that we see a lot, and this is usually a mower gone awry and driving over the leader, which isn't going to allow water to let out into the grass. In this case, the leader probably needs to be buried. And then interior, at the interior of your building, the construction, looking at the walls and the doors. Um, So annually, this can be done annually, is just taking a look. I mean, you're often in your building but not until you really take a look at specific um, materials and finishes of your building you might not see a crack such as in the middle photograph. And usually these cracks, sometimes these cracks can indicate a greater structural issue that needs to be looked at. Also, what you're looking for is water damage, and I'm hoping that your attics don't look like the image on the right, because this is definitely an indication of water, a roof that needs to be replaced and water infiltration. Because once you see failing plaster that's falling onto the floor or water staining, that's a larger issue of water getting through the roof membrane. Fireplaces, clean out your flues annually so you don't have a issue with fire. Also with interior finishes, reviewing all of your finishes, including your wall and ceiling finishes, acoustical ceilings, wood flooring, ceramic floor tile, window coverings, paints and stains and interior glass. You're looking for stains and cracking or missing finishes, loose tile. For your wood flooring, you're looking visually inspecting for warping or excessive wear and damage. And same goes for the ceramic tile. You're looking for damaged tiles or damaged grout or stained grout. For window coverings, are they operable? Do they need to be resecured? Is there excessive wear? And for interior paint, looking for stains or blistering. And then again, often it's if you see something that's similar to the photo on the right, it's often a result of water infiltration. And then finally, your mechanical, plumbing, electrical, and fire protection systems. And usually you'll have a, certified electrician or HVAC repair company that I would recommend having them look at those specific systems annually. Um, have them look at the water heaters for leaks, drain the water heater annually to reduce sediment buildup, checking out all your plumbing, waste piping and vents and fixtures for leaks, for septic tanks, pumping the contents every 3 to 5 years is recommended. Checking your sump pumps, especially before a rainy season, to make sure it's operable. And furnace, I typically recommend having it maintained before the winter season to make sure it's in operable condition. And then all of your fire alarm equipment, smoke detection equipment, we know how the importance of that and making sure you're testing it on a quarterly basis to make sure it's operational. And then electrical service, the main electrical service, we often see a lot of um, uh, things stored in front of an main electrical service. Make sure that that's kept free of obstructions and it's clean. Um, and then lighting, just similar to the site lighting, making sure all your lighting bulbs are changed and the fittings are secure. So this is a maintenance checklist that we use and share with our clients. It goes through all of the major um, areas of your building, your facility that I just went through. I kind of touched on the highlights. This is much more detailed. And it also gives recommendations for how often these specific items should be checked, whether it's weekly, monthly, quarterly, seasonally, or after a storm, or even annually. And then the recommendation of what to look for and how often to check it and what to look for. And then um, all of these things that I've talked about is really about your visual observation and then documenting it. And anyone can use these methods. For example, if you see a crack that's concerning, um, a crack or a wall out of plumb, install a crack monitor and monitor it, check it once every month or once every 3 months. These monitors you can find on Amazon. They're relatively inexpensive and very easy to install and to check. Take photographs and make notes on your photographs. And then the next year, when you go back to check that same item, refer back to your notes and photographs and see if the condition has continued to get worse or if it's the same. Often it's the same. Take measurements and also um, oh, and then also on the right, there is a project that we did, an existing conditions assessment, and we didn't have drawings. We just simply took a photograph and then made our notes on top of the photograph. So the reason I'm showing you this is that simple methods for documenting what you're observing and making sure you're referring back to it the following year to see if the issue has gotten worse. And that's all that I have.
Dana, I love that crack monitor. I've never seen one of those before. That's awesome because you look at those things and you think, oh, it's moved or it hasn't moved, and it's like, did I really see that? It's hard to observe those things over time, so I think that's great. I'm going to ask Bridgette to come back because our audience is mostly Main Street folks, and all the things Dana talked about. I dropped the Keeping Up Appearances one pager into the chat for everybody to have a copy of it. But it's important as a Main Street program to remind your property owners about these things because they forget, did I do that last quarter? Did I not? And so I know Bridgette in Washington, you guys did a mailing once a quarter. Is that right? Do you want to tell folks about what you did for your property owners to help remind them of some of those maintenance things?
Yeah, we put it in the newsletter, but also not all property members were necessarily supporters that got the newsletter. So we tried to email it out as well. Something that I was thinking of, I was like, oh, why didn't I do this? But if I was still doing this, one thing I might do in the future is make it like a thing. Like maybe you have a quarterly, hey, everybody go up on their roof. Of course, your retailers might be different from your property owners, but sometimes they have like those relationships where they are responsible for the care of the building while they're renting it. So finding out who's the right person would be an initial thing that you should do. But you could even make it like social, like, hey, after we all check out our roofs, we're going to go down to the local watering hole, and we can share maybe something else or just be social. So and one of the things I did too, when I was out and about in my district talking to businesses, if I saw something, I took a picture of it, and I would say, oh, hey, you know what, I noticed your gutter has come loose. You see all this water that's soaking into your
Right.
bricks.
Yeah.
If you need help with that, here's a couple of people you could call. Just being that proactive person, because we're all busy and we all know we should do something about the leaking toilet, the leaking roof, the why is my building wicking water. But that's the part where I kind of view the Main Street organization as that supportive net, trying to catch things and throw
Yeah.
them back up in the air for someone to
Yeah.
look after.
Yeah. Well, and all of our Main Street programs now are currently using the Main Street America app Booms Tracker to inventory their buildings and take pictures while you're out doing those things. Like Bridget said, if you see something, a gutter has come loose or something's flapping on the roof that probably shouldn't be, you want to let those property owners know that and not ignore it. And I know that there are some Main Street programs too that their design committee once a quarter goes and does a walking tour, just so they're always familiar with what's happening in their district. And again, at the same time, if you see things, what's the governments at the airports? If you see something, say something. Same thing in our Main Street districts. If you see something on a building that looks odd, or you're seeing those signs of some of the things that Dana shared today, have a conversation with those property owners. So
One
perfect.
other
Great.
thing, a good
That's what I,
partner in this is your city. So one thing I know, like I'm the lead of our Historic Preservation Commission, who partners really well with the Main Street organization, but we do water bills, and so they put a little fun newsletter into the water bills, and so that's another thing that you could slide on in
Right.
into the newsletter, the checklist, or even just a small clippet of hey, even your homes, even if they're
Right.
not historic, can
Right.
really benefit from folks paying attention quarterly.
Yep. Dana, I
that's
think you
what
had
I love. I love about the checklist is we're so busy during the day, and it's so easy to walk by that gutter that slipped. And the
Mhm.
checklist makes you specifically look at specific
Right.
items in your building. And I was going to say, I'd be happy to share the raw Excel spreadsheet file,
Yeah.
because then you all can go in and tailor it
Sure.
to your specific property.
Yeah. Can you put that in the chat, Dana?
It needs some editing, so maybe
Okay.
we can share it later. I'd like to
Okay.
have a few.
Okay. Sounds great. All right, Joe, we're going to turn it over to you.
Okay, wonderful. Okay, share. Okay, is it presenting?
You are good to go.
Wonderful. Hi, Joe Carpenter, as mentioned earlier. I mainly deal with historic preservation work and adaptive reuse in the eastern part of Missouri. And some of this presentation really just gives some little tidbits of items we were often run into and points of interest. So it's a historic building envelope system from a structural engineer's perspective. Right here. Okay. So our agenda will look at basic building envelope systems. We'll look at envelope errors of construction from the 1850s to 1960s, just general system overview, and we're not going to cover every single building, of course. We're going to look at deterioration and remediation. With that, we'll be looking at evidence of issues, and actually Dana did quite a good job on some of those items we'll discuss. We'll also determine the cause of the problem and also example approach to remediation. But all this is really just being presented from an educational standpoint only. Each building, each circumstance is going to be unique. So this is just really to give you a sort of an introduction, and then you can take that introduction and reach out to your local design professional to help mitigate your issue. All right. First one is log cabins. Less common in main streets right now, but either way, pretty important building type for the U.S. With the exception of vertical log cabins from the late 1700s to early 1800s in eastern Missouri, most log cabins you find in the U.S. are horizontal, so we'll focus on that. Usually it's locally harvested lumber, especially in rural areas where it's primarily white oak or old growth pine in Missouri. And it's usually cut within the site itself. Wood shingles are usually attached directly to the top of timber pole rafters and they're exposed just because you really have a limit of materials that are available at that time. Wall clinker, basically your mortar in a sense between the logs. Back in the 1850s in rural parts, is often consisting of like a mud clay, sticks, and animal hair mixed together. If you're in an area that was lucky enough to have access to lime, they might even crush that up a little bit and try to mix in some of the powder. The doors, especially when there was not a blacksmith in the region, they were often constructed with wooden latches and buckskin latch strings because of access to animal product and also the wood. Windows usually used the greased paper in lieu of glass, unless you're close enough to an urban market. And foundations usually consisted of stacked stone. Chimneys, depending where you're at, were sometimes made of logs and sticks with clinked with mud and plaster. So basically, they took the mud and sticks and animal hair, kind of mixed together and created sort of a plaster in the interior called cat and clay. So what was interesting about this is with the cat and clay system, on strong wind event days, sometimes the early inhabitants would have to go outside and check on their chimney stack to make sure some of the embers would not catch that on fire. So it's not uncommon to have to reconstruct from time to time the wooden chimney stack. And here's an example from a village recreation over in Illinois that replicated the original community in the 1830s. Get into basically brick and stone construction, just simple basics. Building on the left side is built in 1836 in Jefferson City, and the building on the right side on the 1890s in St. Louis. Exterior walls are typically load-bearing, so that means they're supporting the structure with the brick and stone. The minimum thickness for residential was usually 2 wide or 2 bricks thick. And when you get in commercial, with some exceptions, usually you saw around 3 bricks thick. Uh, there are some communities where there's no local building codes or building practices that you might only see 2 bricks thick. Doesn't mean it's wrong. It's just it was a little bit outside of standard of care for more urban markets. The bricks were usually hand pressed in urban markets around, up until around 1872. Only about 10% of the bricks are actually hydraulically pressed, where it has much higher strength in the St. Louis market. And St. Louis was one of the first markets with a hydraulic press system. The famous Eaves Bridge that crossed the Mississippi River, because they needed a higher strength brick, the engineers chose to actually use a hydraulic brick instead of a hand press brick. So they actually had testing done on this new technology. And so in 1874, the testing results came out and showed that this brick strength from a hydraulically pressed system was actually superior in strength. Then all of a sudden, it became very common and well adopted throughout U.S. cities. And of course, working its way into rural communities a little bit later on. Lime mortar really mixed, or lime mortar mix to hold the bricks together. That really dominated the U.S. construction until around the 1880s. And then you start seeing some use of hydraulic cement, same product that they use as a binder for concrete. They started mixing some hydraulic cement into city locations and then eventually work its way into rural America as well. And then finally, the interior framing is more commonly constructed with wood, and there's select use of cast iron or wrought steel at that time. But really, leading up to about the 1895, structural steel was not used commonly in building construction. So then you get to the window and door openings of the perimeter building. Once again, pre-1895. So for short spans, usually the exterior consists of either a brick arch, and that's really more for durability, try to keep moisture from coming in, like your outer skin or protection of the building. Or they use a limestone cut element, such as in the lower left corner. It's usually either tapered or flat construction, especially in close to the 1850s. It's more common to actually see a tapered profile, more like a federal style. The interior wise, more common to find actually wood beams at the framed windows. So the middle image at the top there, you'll see a wood beam that slags slightly, very common because wood over time, whatever it initially deflects, after about 5 years, it deflects about twice that amount. So when you built the brick perfectly, day one, 5 years later, even though the building is relatively new, it would have had that deformed profile already, like you see in that image. And then for longer spans, basically you have, or heavier lintels, you have cast iron. So the image in the upper right corner is an image of a cast iron lintel. And cast iron is very strong in compressive strength, but performs pretty poorly in flexural bending. So to do that, they create a sort of trapezoidal profile to create internal arching action. You do not see this type of profile when you get to structural steel later. Then you get to actually how the brick walls were built. So if you're in the East Coast, primarily east of the Mississippi River, it's more common to find three wides or three layers of brick thick, being a 12-inch total thickness. So there's no gaps between Ys, and basically they would mortar those layers or vertical layers of brick together solid. However, once you get to St. Louis and a little bit west, the Masons took a different approach. They actually proactively made the three Y or the three brick system 1 inch thicker. So by doing so, they created 1 inch gap between each layer of brick. This was really done on purpose to try to reduce moisture wicking through the wall assembly because bricks soak up moisture when it's exposed to rain. And by reducing the potential for that water wicking through the assembly, it also reduced the potential for your interior plaster to start getting saturated and delaminating. So a very interesting decision process at that time period. Header courses, as you see in the image on the left side, it's where your brick turns to where you have a short face of the brick and the brick extends longwise in and out of the page. So what it's doing is they're actually physically tying those interior course of brick to the outer course by stitching it all together with a header course. Usually you see those every 6 to 8 courses vertically in terms of stacking condition. And the wall assembly really also relies on a porous, soft lime-based mortar to dry out the wall assembly when you're pre-1895. So in our current construction, you'll also put little wicks, little ways for the wall assembly to allow the moisture to dry out at the bottom of the wall, behind the cavity. In older construction, you really need to rely on the moisture to soak in the brick and then dry out through the mortar that's surrounding the brick to try to keep your interior sound and dry. One thing to also notice is down in the lower right corner, less common in Missouri, but you do find it from time to time, what's called blind headers. So this is a case where you might not see those short-faced bricks. It all looks like it's just a running bond or a long length. Well, the reality is it might all still be tied together by cutting the brick interior side at a corner and running it diagonally. So this is a blind header in case you do run into that unique condition for this part of the country. And then finally, in the middle image here is just an image from an 1890s constructed building, just to show different components you might find. So you'll see in the lower image that it says running or stretcher bond. That's your typical horizontal brick coursing. Then you go directly above, you see the short face of the brick. That's the header course where it's going in and out, tying it all together. And then sometimes you'll run into, especially pre-1900s, horizontal wood beams that are built into the interior face of the brick wall. That's really just to tie the plaster together. But ironically, that does help structurally because it also acts as a horizontal bond beam as well to help with the ladder compliance. And then really just to point out mortar type differences. In the very top, you'll see a very light gray, very soft, kind of crumbly looking mortar. That's a pure lime-based mortar. But then you'll see a darker gray, looks very uniform directly below. That was where a mason had repointed the type in later on. If you started with the type original lime-based mortar, you really want to try to replicate that same material when you're going through repointing. Now we get into exterior wall anchors. So you'll see these primarily before the 1895, maybe 1900 at the latest. And they're more prevalent in eastern Missouri. And they're more important in eastern Missouri. We'll get into that here shortly. So generally, most building codes for urban markets require these. St. Louis building code required these to be attached at 8 feet on center, Minneapolis 10 feet on center, New York City 6 feet. So you have to look at the local codes that was close to your region. But what they were intended for is you had a cast iron star on the outside. You had a cast iron strap that attached the star to the face of the wall to the inside joist. And then that joist ran across the building and attached another star, kind of acting like a jump rope holding both walls together. So the intent was if you're building with through a little bit of differential settlement or movement tends to happen, then at least it's holding the walls from pulling away from the building. That was the original intent. Currently, especially in more seismic prone regions, these are also important to help hold the wall together during a low to moderate seismic event. Now, additionally, if you see an S profile like you see in the upper left corner, that's more likely closer to the 1850s instead of the 1890s because that was done by local blacksmiths. But by the time you get into mass production, like you see in the cast iron star, you're likely 1880s, 1890s. So that's a quick way to try to give a building an approximate age when you're looking at it, unless it was retrofitted later on. And then finally, when you're dealing with heavy timber warehouses, especially where manufacturing was in your local community, The wall anchorage is still present. It's just you might not see it. What usually they did was order pre-manufactured cast iron, looks like a T element with basically a lug. This lug basically allowed for a heavy timber beam to have a notch on the bottom side and to sit on. So whenever the wall would try to pull out, that notch would hold the timber beam to the wall to keep it stabilized. And then, of course, during a fire event, if this beam were to rotate, this beam with the fire cut would rotate out and free itself from the wall to prevent the wall from being pulled down with the beam. And then that same goes with the cast iron star straps. You'll notice that there's little nails here or just a simple little J hooked on the cast iron. This was done on purpose to give it enough strength to hold the wall if you had differential movement, but not enough strength to hold the joist to the wall if you had a fire event. So this would release during a fire event. So it's a pretty creative installation process. The cast iron storefront. So, although cast iron fabrication or foundries were prevalent in various parts of the country, if you're in the Midwest, there's a higher probability that your products came from the St. Louis market. So if you're trying to find who manufactured your cast iron storefront, I would start looking in that area, first of all, at that time period. Now, a great resource for everyone on here is to contact the National Building Arts Center. They have a very large collection of historic foundry cast iron storefront systems, and you just might find the one that's applicable to your storefront. So basically, the way these work is you had cast iron columns. You order your style from a catalog, and so you have four in this case, and then you had a cast iron lintel. This has sort of slope profile, but it's very similar to that trapezoid that we talked about earlier. Or you can get wrought steel beams. You can see some examples that you could order from the catalog that had different profiles and architectural features. So the idea was you ran your lintel or beam across the top. It bared directly on these posts that came down your foundation. They usually had straps at each column that went back into your framing. So if you took down your ceiling, you probably see some straps, cast iron straps running in. And that keeps the storefront from bowing out. And then you have brick or wood built on top. If you notice that this system is bowing out a little bit, take it off your ceiling and see if those straps or ties at the column points are still present. That could be a source of your issue. Now, I should also note, by 1904, structural steel actually started replacing the use of cast iron storefronts. So you really need to understand the date of your building, because if you do have a 1904 structural steel storefront, they're more prone to rusting. And also, ironically, you also have a significantly higher capacity as well. So there's pros and cons. But really, about 1904 is when a testing machine was developed to actually figure out what the load capacities were, and that was done in Washington University in St. Louis, Missouri. Hollow clay tile backup systems. You probably noticed this in Dana's image background as well. Really, these are pretty neat systems. They were developed in the mid-19th century. They're widely adopted around the 1890s with the introduction of a framed building. And actually, the building in the upper left corner, that is actually the Wainwright building in St. Louis, which was from the 1890s. And they use a hollow clay tile backup system because this has a steel framing around the perimeter. They're considered lower cost for installation because you're able to get larger block sizes than the individual bricks, so it cuts down your labor time. They're lighter weight. And also, they help with moisture infiltration as well because you have air pockets within these cavities to help dry out the system. What's also nice is you see these grooves built into the clay tile. That allowed for plaster to really grab onto the product. And as you can see, this plaster is applied directly to the hollow clay tile here. So it's a very quick way they can avoid having weld wire mesh or lath to try to speed up construction as well. But what was interesting about these things is they were considered a form of fireproofing for structural steel. So when you go into an old building, you might not notice the steel being there. You might notice something going around it like a hollow clay tile or brick. That was done on purpose to try to protect the steel from a fire event. And so you see some images down below of how they were assembling all of this. And I should also note in 1 or 2 story residential buildings, especially around the 1930s and 40s, these were actually used as load-bearing wall elements. It's just when you get above 2 stories, highly unlikely that is used for load-bearing applications. Now, we talked about this hollow clay tile, but I do want to note that terracotta can look like the hollow clay tile as well on the outside. Just know that when you do see this, it doesn't necessarily mean this is not a load-bearing wall. It just means you have to do a little bit more investigation. So you'll want to walk inside the building and make sure, see if it's all brick on the inside. If it's all brick on the inside, you're not seeing any columns or any kind of pilasters, then really this is probably just the outer white or exterior layer of brick, which is acceptable for most building codes at that time period. So just a little key note to make sure you look at the inside as well to see if it's load bearing. All right, concrete frame construction. So we're in 1895 to 1910. Concrete frame is a building where you have concrete reinforced columns and concrete beams doing the work, and you're not relying on load-bearing brick walls to support the building. So the first reinforced concrete high-rise building was built in 1904 in Cincinnati, Ohio. The Butler Brothers building in St. Louis, Missouri was built only 2 years later. So what this comparison shows is really this new technology was making its roots in the Midwest. And so it's common to find this up until around that time period or back to that time period. So the way you look for this is you want to look at, especially on buildings that are taller than 3 stories, you want to see if your perimeter masonry walls are 13 inches thick at all levels or if they grow thicker towards the base. If you have more than a 3-story building and it's thicker than 13 inches of base, but it gets down to 13 inches at the top, it's probably a load-bearing wall. But if it's 13 inches thick all the way down in a multi, 4-story or taller building, then you probably have a frame structure. So in a frame structure, the perimeter mason walls are supported individually by the perimeter framing at each floor level below, and the columns and beams are present on the interior side of the building, often protected by the outer white brick. So most time you could usually see, especially in concrete frame buildings, the concrete column being protruded into interior space because the concrete itself, the concrete cover over the interior reinforcing is considered a fire protection. Now, usually you'll see the exterior white or exterior layer brick bypassing, going around the column, but the column usually goes in a couple of bricks thick into the wall assembly. Similar to concrete frame construction, we get into steel frame construction. So same rules apply, about the 13-inch thick at all levels. You want to look to see if there's a pilaster on the outside. This is an example of the Robert Johnson and Rand Shoe Company building in St. Louis, where there's a pilaster protrusion on the outside of the building, but the wall jambs are flush on the inside. So they kind of flip the side at which the pilaster is present, but there still is a steel column inside the wall. So you have to look at both sides. And then what's interesting about this is there's a steel beam in here, but you don't see it. And the reason is they usually took the concrete and they poured it around the steel beam for fire protection. So you might have to start chipping away a little bit of concrete locally with your engineer that you're working with or contractor to see if you have any steel framing there to understand how the building is put together. All right, now we're going to talk about the use of cast iron versus structural steel. So around 1895 to 1910 was a transitional period, especially for lintels, on what product or metal type was being used. So cast iron, which was more in the 1850s to this time frame, was more brittle in tension. That's why we had the trapezoidal shape. But due to its high internal carbon content, the high internal carbon content actually leads to a formation of a graphite film, and this is called patina. So that patina, think of your cast iron skillet that you're cooking eggs in, right? It's a very similar concept. Do you want to get that patina protection? This patina actually will protect the cast iron from any further deterioration or rusting as well. So it's good for long-term longevity, especially at storefronts. Cast iron usually has 2% carbon. Cast steel or structural steel has 0.1 to 0.5% carbon. This is important to note because anything more than 0.6% carbon, you really cannot weld to. So when you're working with your engineer, if you have any major damages or cracks or you need to connect something to what looks like steel element, sometimes, especially in that time period, you want to have a carbon sample tested to see if it's weldable or not. You can weld to cast iron, but it's very difficult, and we'll get into that a little while later. So usually try to avoid it. Now, structural steel angles, which you start seeing closer towards the late part of the 1910 era and then on to current day practice, is stronger. It's less brittle, uniform cross section, so you don't see that trapezoid, you just see a uniform angle or steel beam. But once again, it's transitional, so it's less common up until about 1910. Ooh. URM, so this means unreinforced masonry if you talk to an engineer. So URM lintels. So if you're dealing with a hollow clay building, if you have what is like a 3 foot span opening, and you look up, you don't see any of those cast iron or steel lintels, say, what's going on here? What might be happening is in that upper left corner, you can actually get hollow clay tile to span for low loading. So this might be a residential construction up to about 3 feet. And so what they did in this upper left image is they also included band iron within there. So band iron is usually about a 1/4 inch by 1 inch. So it's like a flat bar inside there. That's providing that tensile capacity when the thing wants to flex there. So if you start seeing basically a calculate tile lintels crack and move, good chance is that internal band iron has rusted away and you'll need to work with an engineer to resolve that condition. Now, if you get into about up to a 5 foot span and you start seeing what looks like trapezoidal, kind of skewed looking halclay tile, then what you likely have is actually something called a flat arch lintel system. So they're actually relying on the skews to create an internal arching action. Think of the ancient Roman aqueducts, right? They're doing that with a flat condition by using the trapezoidal shape to push internally on itself. This doesn't really rely on steel to help with the support. However, they still usually did put some kind of woven wire reinforcing as just a belt and suspender approach. Once again, if you start seeing any rusting or other issues there, consult your engineer that you work with to take a look at that condition. And finally, what we've all seen all over Missouri is really the traditional just brick arch lintel system. So in the middle image on the left, if you see a brick arch really close to the corner of a building, and you look at the side of the building, especially pre-1890s, give that ballpark, or pre-1900s, you're probably going to see the stars. And then right below the star, maybe about a foot down, you'll see usually a diamond profile. So the diamond profile itself, being at a different layer than your typical wall ties, that's usually an indication there's an internal tension rod. Because what happens, that arch wants to do a horizontal thrusting action at the bottom, right? And when that thrust, if you don't have an internal tension rod, that could cause the core of that building to start cracking and moving. So that could be a large source of corner cracking if you don't find that rod assembly. And usually it's buried inside the brick. Now, if you're in the middle part of the wall, you have nice long jams on either side of the opening, which is pretty common for a lot of building sides of structures that you see around Missouri. Usually your side jams will take that thrust in the brick itself and it's not an issue. And then if you're ever curious, you're working with your local design professional, there's a book called Kidder Parker. They're easily purchased in terms of being used on Amazon or other locations. But within there, they usually gave standard care practice in 1906 for your keystone depth versus span and rise for your arch assemblies. So this is a good table to work with your engineer if you're trying to determine if it was built correctly in the first place. So we're talking about these external stars and other means. Let's talk about what happens when you don't see the stars, especially in the eastern part of the state where wall anchors were codified. So if you don't see those, but you know you have a 3 brick thick wall system, but you do see a strap on the inside, if you open up the ceiling, you likely have an internal anchor condition. So they usually twisted the cast iron strap and made sort of vertical kind of toothing that goes right behind that outer layer of brick into the mortar bed. Or you might have a pin and then the cast iron strap just wrapped around the pin. Either way, it's there. But if you start seeing kind of movement in the wall locally or see some damage, you might need to look at doing some retrofit measures that we'll look at later. And same deal with basically the heavy timber building that we talked about earlier down the lower image. So again, usually have a cast iron sort of seat assembly that locks into the brick that's holding it all together. And there's some other examples on the far left side. If you have structural steel, how it interacts and ties into the wall as well with these internal anchors. So key takeaway is you really want to look for steel and wood frame to see if there's a little cast iron strap or steel strap that comes out of the wall and to the side and start looking for damage there. Ooh. All right, so metal detailed wood sheathed cornices. Real fun stuff. So these, of course, are architectural projections, usually not directly structural, but it's just to give the building more of a prominence, especially on Main Street. Missouri, you'll find a lot of this as well. So overview, if you have a wood frame building, you likely have basically a lightweight cornice protrusion for the architectural feature. The protrusion is usually a copper galvanized metal sheet on top of the cornice projection. And then for the vertical surface of the cornice projection, usually it's either wood, copper, or galvanized sheet. Especially back in the 1890s, it might be more closer to wood. But as you get closer to 1910, there's so many products out there you could purchase. It's just simpler and faster for the builder to use galvanized pre-molded sheets, as you see in that upper left corner. Typically, for wood constructed buildings with brick bearing walls or wood bearing walls, you'll see just simple wood 2x4 outriggers. And you see in that upper right corner image, you'll see the wood outrigger will go through the brick wall, so it bears in the wall, and it's toenailed back to the interior wood rafter framing, and then it projects out to hold the cornice assembly. And if you see the image in the upper left corner, you probably notice in that blue leader, there's these little nail heads. There's basically them attaching the metal sheathing to the wood outrigger locations. And then down the lower left corner, full disclosure, it's my own house. Trying to get images for this presentation. We were looking, this is basically built in 1890. And so the construction type used in this one was a copper gutter pan. And this was set directly on top of a wood horizontal 1x decking. And that was all supported by wood cornice or corbel elements that were attached to internal wood blocking. Similar to the image that we saw earlier today, where there's internal wood blocking built within the brick assembly. Now, there's also probably an outrigger as well, but that's on a project by project basis. So really, for these type of systems, what you want to look for is source of water infiltration, just as Dana said earlier. You want to look for outrigger movement or rot. A lot of times, these pan assemblies will start to leak over time, and they'll start rotting out either the wood outrigger below or the wood blocking. And you really want to make sure that's in good shape. And then really, you want to see if it's metal or wood clad rot, just because if you start not addressing it and there's a little bit of movement out there, that could become a fall hazard for occupancy. But in general, because they don't insulate these systems and they're a little bit airy, if you do get water into them, it's more common than not that the wind will actually dry out the wood if it gets a little bit of moisture exposure for these outriggers, so you don't hear of these falling off as often. Alkali tile backup systems. So the image in the lower left corner is St. Louis City Soccer Club's headquarters, just to show you visually what this might look like. But really, these had different types of anchorage. So in the upper right corner, you'll see an image of a residential construction. So for residential construction, they'll build out the hollow clay tile as a load-bearing element for 1 or 2 story buildings, much taller. It's set basically a 2x8 horizontal plate on top for wood support, and it has a through bolt that goes through with a plate attached to the bottom through bolt. These usually go down about 2 courses of the hollow clay tile. So that way, if you had a strong wind event and your wood rafter starts to try to uplift from the uplift wind pressure, it's grabbing onto that anchor and that 2x8 plate, and it's really grabbing onto the hollow clay tile to help hold it down. Now, if you have a very strong event, and if your mortar's in rough shape on the hollow clay tile, then you have a potential failure point there. But for the most part, general loading, it works pretty good. And then, of course, if you do have in the upper left corner, just wood ledgers for your ceiling support to these hollow clay tile systems, there's different kind of expansion anchors, toggle bolts, collapsible screw socket, and self-clenching nails that you might find. Pretty common at that time period. And that's about it. All right, so now we're into the 1910 to 1940s. So you might see the building on the outside and say, oh, this is a brick-built building, maybe it's brick load bearing, but looks like it. But the reality is it might not be at that time period. And likely it's probably not really. So what's interesting about these is you want to take a look and see really where the brick itself bypasses the concrete or steel beam. Because usually what happens is at that time period, they would install little galvanized kind of corrugated clips. And I've been in so many buildings where we've seen movement where the original builder forgot to turn down the clip and embed it into the mortar of the brick from day one. So with that, basically what happens is the brick starts, especially with water infiltration and expansion of the brick might start bowing away. These clips are very important to this type of system. So if you start seeing that, you might need to talk to your local mason, open up a section, see if these clips are installed correctly, and also see if they were rusted through or not. And of course, once again, here's just an example in the lower right image, if you look at the presentation later on, or what some local building codes would identify for load-bearing brick wall thicknesses. And as you see, as you get taller and taller, the bottom floors are thicker, and as you get towards the top, that gets down to that 13 inches that we talked about. All right. Terracotta cornices and connection details. So the use of terracotta in brickwork, the building on the right, lower right, is the University City, Missouri Police Headquarters, built in 1903. You'll see a very ornate sort of terracotta projection. Usually when you see this type of system and not the use of wood or metal cladding, usually have a steel or concrete building because you really need something robust to attach to. So a great resource if you do run into this type of system and start seeing a little movement or deterioration would be the National Terracotta Society. You could look them up online. But really, in 1914, sort of the height of when they're installing these type of systems, there are different typical national building examples of how to put various architectural features together on a building. I think there's, I mean, this is plate number 70. So at least for these examples, I've gone through at least 70 of these to get some images over. So what's interesting about this is if you have a short projection, maybe you're 6 inches or a foot out from the edge, basically the terracotta itself usually has a J-bolt inside of it and then a horizontal rebar that's running parallel with the terracotta band. That J-bolt just goes into the brick assembly beyond and they'll grout inside of the terracotta. But if you get into larger projections, really sticking out there, much more than a foot, sometimes they'll have to supplement steel outriggers or steel frame beyond to really tie the whole assembly together just because there's too much eccentricity trying to pull the wall. So once again, take a look at how far it's coming out and go to the National Terracotta Society, download the older plates history, and talk to your local design professional about ways of mitigation. We'll give some examples later. So then really around 1910, 1940s, this is where we started seeing more of the use of something called steel shelf angles. Steel shelf angles are really a continuous steel angle that's bolted at a certain pattern all around the perimeter of the building. So instead of just having a loose lintel or lintel that supports just from jamb to jamb over a window, this angle goes around the entire building. Usually a good indication that you're going to have this is if your window assembly goes right to the bottom side of your building's perimeter beam. So if you see in this upper right corner image, this is at Missouri State Science and Technology in Rolla, the Fulton Hall building. This is an example where there's a shelf angle or steel angle that has J-bolts that was cast into the concrete beam. So that means that this angle is continuous even beyond the windows itself. Another example would be down lower left corner, same campus, same building, ironically, just in this case, they had the use of steel for a different phase of the building. So in this case, they actually had a steel plate that was riveted to the bottom side of an internal steel beam. And so the steel plate would support the brick on either side, and then the interior layers of brick or white brick would support directly on top of the steel beam. And the bricks on the outside would just transload through this cantilevered plate on both sides through rivets back into the steel beam. And then, of course, when you get to loose lintels, there's an image in the lower right corners from Alton, Illinois. This shows one that's pretty badly rusted. But either way, usually it's just is below the roof framing fair distance, so it's below any kind of steel beam or concrete beam, and it's supported directly 4 to 8 inches into the brick jamb on either side. All right, for those that are interested, this is 1930s wood construction. This is mainly focused on residential building. The image that you see is from a 1936 Sears home catalog, so more representative of an average build for the U.S. versus just a localized township. So what's interesting is you'll find this advertisement. They basically built it very similar to what we do currently. 2x4s are placed at 16 inches on center. We had one bottom sill plate and two top plates, which are basically your horizontal flat 2x. And the difference is instead of having plywood sheathing on the outside, they use 1x8s or 1x10s. And what they did is they actually had basically an airspace between the outside sheathing and your interior plaster. And at that time period, they viewed that as your insulation. Under current practice, we would not. We would view that as a problem. But the interesting thing is they used an exterior asphalt impregnated felt paper to help reduce air infiltration and also moisture infiltration. Worked great when it was built originally, but over time, that impregnated felt paper does deteriorate and lose its ability to reduce that infiltration. So the problem is if you start taking an old building like this and trying to pump in a bunch of, let's say, fiberglass insulation without mitigating that paper product on the outside, then we're opening up to a sponge effect on the interior wall system. So really, if you're going to look at trying to provide some kind of insulation, you want to use something like a mineral wool, or I hate to say this, you need to remove your siding and replace your likely deteriorated outside felt sheet paper and go with a more modern product before considering a different type of insulation. Mhm. So with that, we're now into 1950s and 60s. So when you're dealing with an aluminum storefront building, very important on Main Street, Missouri, right? There's some key things to consider when you're considering alteration to the storefront. So aluminum storefronts are very popular. If you're initially considering purchasing a building or you have an existing building and notice that there's any water staining or anything towards the bottom of your storefront, if there's an opportunity to peel back some localized conditions on the inside, to take a look at your sill, because a lot of times what they did is they put a 2x wood sill directly on top of the concrete pavement or concrete edge, and then built your aluminum storefront directly above there. If you have any kind of wood that's within 18 inches of grade, that the concrete will actually have any kind of moisture wick up into the wood itself. So this can actually cause problems for deterioration. So we want to point out that this is a primary source for problems. If you're buying one of these buildings, you want to look at the sill condition. Additionally, before you start tearing off the storefront and putting on new assembly, I do want to make note of something called mullion bars. The mullion bar is actually a structural steel strongback element on the back side of your aluminum assembly. So if you see that blue image down the bottom, those are the darker black line, that's a mullion bar. Those are actually helping strengthen your aluminum system, storefront system for wind loading to keep it from bowing in too much. So you really don't want to start cutting in or altering those mullion bars. Additionally, in the lower right image, this is from Principia College in Elsa, Illinois, at the Marshall Brooks Library. Great building all in all, but I do want to point out that this is an example where they had basically a stone mullion system for storefront, but where they actually said the window manufacturer needs to provide reinforced mullion bracing, so similar to mullion bar, but in some applications, there was structural steel at those locations that were supporting the building. So it's very important to work with your engineer if you're going to make these storefront alterations to make sure you're not unintentionally taking out a steel column and thinking it was just a mullion bar. So you do run into the case from time to time. Ooh. Stucco. So it's less common in Missouri for good reason, but it is basically a plaster made from cement, sand, and lime, traditionally applied in 3 layers. The reason it's a challenging product in this region is due to humidity and freeze-thaw conditions. So if stucco, because stucco itself is has a high porosity and moisture absorption. So really, if you have a stucco system, you want to make sure you have a paint that is able to dry out, has the ability to allow moisture to escape if it gets in. Because what happens is, you'll find here's an example of the Shanley building in Clayton that was involved with in the restoration. This building had a non-porous, or had a paint that would not allow for drying out. So moisture got in, because all paint cracks over time, you get little infiltration points, got stuck behind the stucco, and then caused for delamination and cracking. Now, during freeze-thaw events, over in the left image, this is more what you find in residential, which actually is a decent system as long as you're using the right paint application. This is where you have that 1x wood board siding that we talked about earlier. Then you have little sort of spacer boards in between, and then you have your stucco on wood or metal lap. The good thing about this system is you have your air gap between or behind the wood laths so that if you do get a bit of moisture wicking, because once again, stucco is very porous, then you have the ability for at least the moisture to work its way down and get out of the building. But once again, trying to use the appropriate paint system, work with stucco restoration contractors is a good idea. All right. Now, finally, for the 1950s through 60s masonry envelope system, I just want to point out that this is a transitional time period where you find all sorts of different build systems. So over on the left side, we'll find that the masonry system, basically a CMU backup with a brick veneer, was built tight all the way around the steel framing. And also the outside brick veneer was tied in with the CMU as well. So this is from 1954. But then you go all the way over to that right image from 1958, actually, same time period, only 4 years difference. We'll notice that we had a CMU backup, but the brick veneer was completely separate. So instead of tying the brick coursing into the CMU, what they did was they used those galvanized clips we talked about earlier. So you really need to understand if there's any header courses or anything else that would cause this condition. But this Emerson Hall building in Raw, Missouri was a trick building because it has what looks like to be a header course, but that's just an architectural feature. It did not actually extend into the CMU. This is just to create the look that those header courses and those galvanized clips were used for the whole wall assembly. And then here's an example in the very middle from a project in Elsa, Illinois, just across the river from St. Louis, where they actually did two separate masonry courses, but separated by about an 8-inch gap or an 8-inch gap. So what was interesting is they actually celebrated the fact that moisture will get into here, hit an interior rigid board, and come down and start wicking out of the wall assembly. This system also allowed for steel columns to be built internal to the wall. So if you walk in the interior of this Howard Center in 1966, you would not see perimeter steel columns and you see brick, so you'd automatically think this is a brick load-bearing wall. But the reality is there's hiding the internal steel structure. So the key takeaway is talk to your design professional. Each building system could be different, especially in this very volatile time period where this building systems are quickly advancing to different types of approaches. And then 1960s through 1970s, the use of precast buildings became pretty popular. Pros, they're quicker to construct off-site, similar to steel buildings, tighter quality control, and unique custom profiles. The cons is, especially in parking garages, where the precast connects to the column. You'll see that there's on-site field welding in that left image. Any galvanization on that clip would have been burnt off during the welding. And if you had a good contractor, they might go back in with a cold applied galvanization, but even doing that is not perfect. So from day one, you have a source of potential rusting. And you can see in that middle image in the bottom where those connections started taking on moisture infiltration, started rusting, and the rust pack pushed out the concrete cover, then exposing the rebar that was into the precast to rust or to moisture infiltration and further exaggerated the problem. And then also, again, 1960s, here's an example from Belleville, Illinois, right across the river from St. Louis. This is a precast column system, both used for architectural and also structural purposes. Based on the fact that they use the incorrect paint, trap the moisture in, and then also the reinforcing was a little closer to the surface than what would have been the required specified distance, which is 2 inches for exposed concrete like this, the weather conditions caused the rebar to start rusting internally. So in those cases, you have a structural element outside of just being architectural as well. All right, now we're going to talk pretty quickly here, keep on time, about deterioration remediation. So this is an example of timber construction. On the left side, basically you have a timber column that extended directly into soil. This is circa 1870. And you'll see that it has more of a toothpick profile of the rot. So really, if you see that lower image, you can see kind of an approach that was, I guess, discussed with National Park Service and approved to mitigate this condition. But what happens is when the soil is damp around the actual post itself, it will rot from the outside going towards the interior, creating sort of toothpick type rot profile. However, when you get above ground, and you have a painted surface, especially when you're pretty close within that 18 inches to where the water can wick up through the concrete in that middle image, it's more common to have the rot occur from the inside going outside. It's So you might tap the outside of the timber and say, oh, this is great, there's no problem. The reality is, if you know it's close to the bottom and you see little signs of paint peeling and other issues, you probably actually need to bore the column to see if there's internal rot. In the engineering community, it's more common to see engineers accept an internal rot of less than 30% and then do a wood densifier and basically a wood epoxy for repair in localized patches. But most of the engineering community, if you're more than 30%, you're going to see most engineers advise to actually cut out the bad section after you temporary short and then go through and do like a scarf joint bolt reconnection configuration. And there's other examples the National Park Service will accept as well. Brick, you just want to make sure that you're addressing the right mortar for the building to be able to breathe. So in the upper right corner, you'll see an image from a hydraulically pressed brick circa 1890. And the middle image, you'll see a soft brick. So it's not hydraulically pressed from an example in 1844, St. Paul Church. So some examples, if you're getting that soft brick, you see more of those alligator profiles in the brick surface, more likely you have a soft brick. And especially in rural Missouri, leading up into the 1890s, more likely you had a hand-pressed soft brick as well. But some common things to look for is down lower right image, you start seeing facial blowout. You probably have trapped moisture in the inside. That's going to see you as well. If you start seeing that you just have sand at the bottom of your wall assembly, then more than likely the lime portion of the actual mortar started leaking out from internal trapped moisture, and that'd be a sign that you have bigger issues to contact a professional. And the part where it looks like there's a bunch of white lines or dripping, that is called basically efflorescence, where the salts from the internal masonry system is starting to leak out. That is a sign that you have trapped internal moisture. And then the bottom left image shows where the wrong mortar was used at one point in time for repointing. Moisture is trapped, and then during freeze-thaw event, it caused the outer part of the clay brick to bust out. So these are all signs to discuss with your professional as well. Now, if you get a wall bow, brick wall bow is where the whole wall assembly all whites bow together. If you do start seeing that and your wall bow is more than 1/6 of the wall thickness, an engineer should be involved. If the wall bow is bowing outward or inward together, the root cause of that system must be addressed prior to actually mitigating the wall bow itself. Usually deals with either foundation rotation or settlement, or if your parapet had any kind of mortar deterioration on the inside face, that mortar deterioration caused the parapet to lean inward and then cause the first level below it parapet to start bowing outward. Those are usually the signs that we find often. If your engineer finds that your wall bow can be stabilized in place, they might do something called strong backing. FEMA 547, it's meant for seismic rehabilitation, but it's a great resource as well to find different strong backing details you can discuss with your engineer. And this basically, the use of cast iron stars with threaded rods through to your internal new strong back, a vertical steel element on the inside, is an acceptable way to stabilize the wall from getting any further movement. Now, if the whole wall isn't bowing, but just the outer layers moving, that's called outer wide separation. So the image on the right would be a good example if you're looking at your building to see if it's outer wide separation. Your header course, the brick that's actually pulling inward, that's a sign that your outer layer brick is all moving together and separating from your inner core. So look for that punching mechanism that you see in the right corner. Another sign would be a heavy efflorescence water damage in the middle image, and you start seeing the brick peel away, but the rest of the wall looks to be fairly plumb. And then finally, in the left image, you'll see where the outer brick, especially from rust jacking from the actual lintel, starts moving. And then, basically, with all that being said, these are just signs that you talk with your engineer on how to stabilize. But if it's minimal in a localized area, the use of stainless steel, helical ties is a pretty common approach for restoration engineers. Otherwise, consider rebuilding the localized section. Oops. All right. Another sign is called rust jacking. So if you have a steel lintel, you start seeing a bunch of flaking steel above your lintel, like you see here, and then you start seeing diagonal cracking in the image above. That's a sign that your steel is going through rust. Now, it's not always the end of the world. You need to actually measure the thickness of that rust pack, the flakes. Whatever that rust pack thickness is, divide by 8 or 9, and that will actually tell you the amount of actual true steel material loss. So quite often, you could actually save the steel lintel in place if you have your engineer review the condition. But you want to clean that and repoint and repair the brick as well during that process. But really, if you get much more than about 15% of your steel loss, you might start considering replacing the lintel as well. And with shelf conditions that we talked about earlier, usually if your shelf where it's J-bolted into the concrete perimeter beam in the lower right corner, usually if your J-bolt itself is starting to deteriorate, you'll get corner spall of the concrete beam. So in that upper right corner, you'll want to talk to your engineer about patching that corner spall condition prior to restoration. So if your shelf angle is in decent shape, you have very little material loss, but your J-bolts are damaged, then you want to go ahead and drill and epoxy new bolts adjacent to the original ones to reattach your shelf back to your concrete system. If you have a condition that you see in that middle photograph, where it's kind of doing an S profile, almost like a wavy profile or a roller coaster, usually what this is a sign is that it's a steel plate that's riveted to the bottom of a steel beam, and that rust jacking is causing the plate to deform between each of the rivets. So this is a case where if you have severe movement like this, in this case, we actually replace the steel plate, but this is where you want to talk to your engineer and see if you need to replace or you could repair and replace. Oops. Cast iron stars, especially in eastern Missouri, if you have a major renovation. Eastern Missouri, the building code requires you to actually tighten up more wall anchors than what was originally there. So if you're doing that, then you'll basically need to install a new cast iron star, and there's plenty of foundries down in Texas. I think these are $8 a piece. Run a thread rod through the wall, and then Stemster Mytech are main suppliers of what are called shear wall tie downs. This assembly will give you the equivalent of what the building code needs, depending on the loads that the engineer comes up with. And that's the middle image on the right. Alternatively, another approach would be to run your new star, between joists right in the middle with thread rod through, and then you run through a new 6x8 solid wood blocking that's spanning between existing joists. This gives you a little bit more flexibility on exactly where you're drilling through the wall, and also allows you to share load between two joists, which also improves the condition. Once again, more of a topic for Eastern Missouri where seismic compliance comes into play on major renovations, less so much on Northwestern Missouri. And then finally, also dealing with the wall attachments. If you never had the cast iron stars in the first place, there's also very typical mitigation details for the wall anchorage where you can drill and epoxy new anchors. They require a 22.5-degree angle into the wall assembly, and plenty of details you can go back to here and refer to with your engineer. Now, we talked about not welding to cast iron earlier. I just do want to point out that in rare cases, especially if it's an ornamental feature that needs to be salvaged and there's no other option, you can use what's called a nickel-based, and sorry about the spelling in the lower right corner, but you can use a nickel-based welding procedure. The product is called a Tech Rod 99 if you have a welder that you work with. And they need to use this nickel-based system because it's the only one that will actually work with cast iron. So what you have to do is you have to, first of all, grout out or shore up the building, route out the actual crack, and then go through, heat up the cast iron to 500 degrees, weld 1 inch, cool it down with blankets, and then do the next 1 inch procedure. So it's very time intensive. And then if you're down in Texas, there's another option on the right side for stitching, but the field expertise in Missouri is not present. And then terracotta. Once again, we mentioned all these unique systems, J-bolts going through. If you do run into a terracotta element that's peeling away, you can talk to your engineer about drilling and epoxying new bent rebar into the system, similar to what you see in this lower right detail. And then, of course, you have terracotta cladding that's going up vertically in the building around a perimeter, but you have some localized panels that are peeling away. In the upper left corner, you could talk to your engineer about installing those stainless steel helical ties. But when you install those, you want to install them at a 45-degree angle. So this is a plan view looking down. Because if you install it straight in, then there's a better chance that could pull out because soft clay brick doesn't hold on to these anchors very well. And then down in the lower right image, just some examples where there's terracotta cladding that was at one time attached to internal steel beams. These are some detailing concepts that you can go back to this presentation later and talk to your engineer, see if this will work for you. And then if you get into actually broken terracotta, the wait time to have a replica terracotta made is usually around 2 years right now. So usually that doesn't work for developers. And so the more common practice that we see in our market in St. Louis is to use something called glass fiber reinforced concrete. And you see an image in the lower right corner. This is actually a replica piece of an original terracotta. What's nice about these, you can have them replicate the original piece. There's no internal steel. It's using fiber, so you have less of a chance for internal delamination over time. And then due to time constraints, we'll move on. When you get into Haydite CMU, we talked about that stucco earlier. Haydite is basically using clay, shale, or slate that's dried out instead of a limestone. So it's more of a dark gray cinder block. What's the problem with this type of system is if water gets through basically your stucco and gets trapped inside these voids here in that lower left image, that will expand during winter conditions and cause delamination. If you do have to run into a Haydite block, use a low strength patch mortar when you're talking with your engineer. And of course, just when you're talking about the brick being built tight around the steel framing, just know that you might have that rust pack we're talking about earlier. So if you see any bulging on the outside of the wall and you know it's built tight around, you probably have to remove the bulge locations, clean the steel, and see if enough of the original steel is remaining. Most engineers will consider less than 15% loss something that you can manage, and more than you need to start looking at repairing or replacing the steel beam altogether. And then if you deal with concrete restoration, you want to remove any of the loose concrete, sound it, and then start splicing in new rebar, drilled epoxy. Once again, try to go at an angle when you're going in with any kind of new ties, and then use a corrosion inhibitor, basically patching mortar. So that way, if moisture starts getting in there, it has the ability to reduce the potential for future rusting. Some engineers down the lower left corner might even use a cathode element as well. This produces an electrical signal through the rebar that helps track any kind of chloride ions to the element and protects the rebar as well. Kind of an extensive system. And that is it.
Joe, that was amazing. And I'm not an HP person. I'm sure Bridgette was eating this up, and folks on our call that have that HP background were just eating this up. So I really appreciate it because I have zero knowledge in that area, and that was really, really good. We could probably have you talk for a couple more hours. And so I know some of you may need to go because it is 10 o'clock. We're out of time, but we're going to keep recording and, of course, putting this on YouTube. So stay around if you can, because I want you to hear what Bridgette has to say about some incentives and some programs that we offer here at Missouri Main Street. And so we're going to keep going. And if you need to go for a meeting, please do. But just know that we'll have the rest of this on YouTube along with the whole thing. You can catch up later if you need to. So Bridgette, take it away.
Okay, so, hi, I do want to say that was amazing. If you are a Main Street director or on a design committee, you need to definitely bookmark this link to come back to. That was a lot of information to take in. I was totally absorbing all of it, loving every bit. I learned a lot. And so you will need that at different points as you go forward. So you can come back. That's the nice thing about having these recorded. So we're going to jump in. Why funding matters, of course, but not only to me, why funding matters is because I want to save all the old buildings, but it does, preservation has many things to many people, but it is a community value and a financial investment. Of course, I want to keep the buildings, but we also need to keep them vibrant and occupied. And we really want that long-term sustainability for you and your district. So there's a lot of tools. Of course, everyone always thinks of the historic preservation tax credits. We're going to have several slides. That's the bulk of what I'm going to talk about today, but also some other gap financing tools, grants and other nonprofits you can work with, and some public-private partnerships. So that's really, those four things are what we're going to hit on in the next 20 to 25 minutes or so. So let's jump right into the Federal Historic Preservation Tax Credit. 20% credit for those certified rehabilitation of income-producing historic buildings. So that's important, the income producing. Really, I was talking with Dr. Stephen Hoffman yesterday, and he's like, really, if I had it my way and I could tell anyone how to do it from the beginning, it would be put your team together first before you even buy a building. You need to have that preservation consultant, the CPA that's knowledgeable about how all of this works, and the architect, because how you structure, how you purchase, and how you own the building is very important for when you go into these tax credits. That's not to say that you can't restructure before you begin your project, but it's just immensely important. I have a project specifically in Washington, Missouri, that the ownership wasn't structured like it should have been, and it really reduced their ability to use their tax credits and even to sell them. So, but it is administered by the National Park Service and the IRS, and then locally, at the state level in our State Historic Preservation Office. It says you must follow the Secretary of Interior standards for rehabilitation, and I put in within reason because this is definitely a negotiated process, and that's another reason why you need that historic preservation consultant. And it must be a certified historic structure, meaning it must be individually listed on the National Register of Historic Places or listed in a district. So that's another really important thing, especially if you're starting out in Main Street. One of the first things that you should be doing is checking out a district, and that's something you can get a grant for if you partner with your city and have a certified local government, Historic Preservation Commission. Those kind of go hand in hand. They work great with your design committee, and there's funds available that you can access through your city. The Missouri Historic Preservation Tax Credit is by far probably the best in the nation. I mean, I think it is the best in the nation, and I think I'm not even, blowing smoke here because it's so high. So in St. Louis and Kansas City, they get a lower credit of 25%, but outside of St. Louis and Kansas City, it's 35%. And so when you pair that up with the federal, that's 55%. It is so high because they're asking you to do things that if you were just basically renovating, you might not do, i.e. the wood windows. So they're incentivizing you to do the more quality, higher end, at times, renovations. Administered by the Missouri Department of Economic Development, but also in hand with the State Historic Preservation Office. These state credits are transferable and can be used as collateral for loans. Banks love them. U.S. Bank in particular loves to buy Missouri HP tax credits. And I haven't checked lately, but in the past it's been as much as 90 cents on the dollar. Eligibility basics. Again, we talked about it being individually listed or in a district that must be income producing. So you can kind of see my eligible example, a downtown building with apartments above and retail below, but not eligible a historic single family home that you live in. So that's for the federal. You can use it for your historic single family home that you live in on the state side. So maybe you could, if you are doing it personally for a home, you could just access the state credit. It does require a substantial investment, and there's a whole calculation for that. We're not going to go that deep into the weeds, but it's basically roughly the value that you purchased it minus the value of the land, and then over 50% of that. I am not a certified public accountant. That's a really rough estimate, but just to give you an idea of what is a substantial investment. It's all about depreciation. So the longer you might have owned something, the more depreciation there's been on the building, that lowers that threshold as well. So only physical permanent improvements qualify. So like windows and roofs and floors. Stephen told me of one example where they actually tacked the rug down because it was part of the building when, historically. And so but if they had glued the rug, they went back and glued the rug, and that they were able to get that to be part of the tax credit. So that's the kind of an example of the permanency portion. As you can tell, a lot of this is very negotiable, but building your team is essential. Do not do anything before you hire a historic preservation consultant. You need to engage with a qualified CPA, not just any old CPA that works in your district. You need someone that understands tax credits, specifically the historic preservation tax credits, and how ownership needs to be structured. When you have that preservation consultant in line, they can probably point you to a qualified CPA as well as an architect, engineer, tax professional, all of that. Your consultant's fees, what you're going to pay them to help you, are eligible for the tax credits. There's a 3-part application. The first thing you need to know that they're going to ask you is it individually nominated? Is it in a district? And so that's great if you can say yes to one of those. If you cannot, you would want to do an eligibility assessment. So it's a 1-pager you fill out, you give to the State Historic Preservation Office. They can kind of say, yeah, we think so, or this is going to be a hard sell. So you will have to know that before you get started, or you're really going to have no access to these credits. All approvals required before any work or spending. So you can't be like, I'm pretty sure I'm going to get approved next month, but I want to get ahead and order my windows. Then you would no longer receive tax credits for the windows you purchased. So really, truly, nothing can happen until you have approval. You need to retain the character defining features. So when you're looking at a lot of those buildings that Joe showed you, like the terracotta, that would be a character defining feature that you have to keep or repair. So they're not going to let you just take down that terracotta and, brick it in. So that's the deal. That's why they're incentivizing you with these tax credits to put those character defining, keep them, fix them, put them back. The process is completely negotiated, and that's where your historic preservation consultant is so essential. They hopefully have done lots of these projects. They know the architects at the state really well, and the preservation office. They're going to have that relationship and say, I totally get why you want us to do these kind of windows, because they're very character defining for the facade of the building. But what about me being able to put that HVAC on the roof? There's a negotiation process, and you definitely want someone that's been in the negotiating chair before in that area. So the benefits and challenges, the tax credits are not easy. It's not easy. It's not a slam dunk to use these credits. And so I really don't want you walking in thinking that this is just the easiest free money you're ever going to come across, because it's not. There are many benefits. A major financial incentive, potentially getting someone to help you with 55% of the cost of your renovation, is outstanding. It encourages quality investment with subsidies. So they want the higher quality window, but they're going to help you subsidize that. So maybe you wouldn't put wood windows back in, but because you're using the tax credits, they're going to help you with that cost. So, of course, we know it boosts downtown and community revitalization. And then the challenges, timing. It's going to take much longer than you think it is to work through the process, to wait for approvals, to process the paperwork. And so I just want you to have your eyes wide open when you go into this. You do need to follow the standards, and you have to pay for everything up front. And so you're not getting reimbursed really with the credits until the end, until everything's done, the project's been inspected and certified, and then they will issue the credits. So here's just a quick example: federal 20%, Missouri 35%. If you have a $500,000 project, you would see $275,000 in credits. So these are dollar for dollar credits, so not a deduction. It's a credit. So if your liability to the state in any given year is $5,000, well, you're going to take $5,000 of those credits, apply them to what you owe, and then that negates your tax bill. A lot of folks don't have that much tax liability, and so that's why it's really important, especially on those state credits. A lot of folks just sell them to someone like a U.S. bank. I think Ameren purchases them as well. So that's something to think about. You really want to have to think this process out before you get to the fun part of working on the actual building. So there are other incentives. We talk a lot about gap financing and layering financing opportunities when you work on buildings. So there's tax increment financing, community improvement districts, grants, and other local incentives. So think of the credits as just one piece of your funding puzzle. So tax increment financing, that's something that you work with your city or county, depending on who's in charge of the area that you're in. And it uses future tax increases to fund improvements. So typically someone like a school district is like, oh, I'm not so excited about a TIF. But it's something that can be used really appropriately in revitalization efforts. We've used it in Washington, immensely successful program for infill housing, high density housing. There's also a community improvement district. There's lots of wonderful examples of those all over Missouri, in Lee Summit, Missouri, and Cape Girardeau are just a few that are at the top of my head. Those are local sales tax or property assessments to fund upgrades. So each, the TIF and the SID, and even the NID, it's just a little different. Any of those, if they're in your community, you want to understand how they're set up and how they're going to process. So for us, when we did the TIFs in our downtown district, there was a small set aside for small programs, because these are like multi-million-dollar developments that are in these TIFs. And so someone that is rehabilitating their facade and maybe their second floor is not, it's not worth the lawyers and the fees to set up a TIF just for a smaller project like that. So we purposely structured it so this big development project and this TIF would have some smaller money set aside to give out for other renovations on buildings near it. And so that's been a successful program that Washington has in place. I'm not as familiar with the CID. We never got one in Washington. Hopefully that's a future thing. But I see Keith's here. You guys, I think you're very familiar with SID's funding projects.
Yeah, typically community improvement districts are funding an additional funding model for a Main Street program, but it can be used on a property. The Elms Hotel in Excelsior Springs needed to undergo a $20 million renovation. And so they put a CID just on the hotel property. And so an additional 1% of sales tax that the guests paid then helped pay for the renovation that they were doing on the building. To your TIF comment, Bridgette, there's a newer tool called Chapter 353 tax abatement that could be a good financial tool for smaller projects, renovations, rehabilitations, for a property where you're abating the increase in property taxes for that property owner, and they get those property taxes back every year, and then could be used to help pay off that rehabilitation. So Chapter 353 is something that more and more Main Street districts are tapping into and utilizing to get some of those white elephant properties, but also helping property owners who need to, maybe they invested in their property 20 and 30 years ago, and now it's time to do some repairs and things on that building, and so they can abate those additional property taxes and help out with that project.
I need to add that to the slide because we actually did use that. We had a shoe factory that was renovated, and they didn't want to wait and go through the tax credit process, and so they said, "What else can you do for me?" And so we did use the 353.
Yeah, the costs are less to get it set up. The city is in control of how that works, and so local control with a 353.
Yeah, so I definitely need to add that to the slide. It's actually very old, but we're just getting into using it in downtowns.
Yep.
So government partners. So you really need to understand your area and what opportunities you have. And this is where your Main Street program can be really helpful. Does your city have something available through their economic development department? Does the Main Street program have any funding available for facades or interior renovations? Do you have a local development corporation? So we have two local development corporations. One, actually, funny enough, is called 353. When they started in the 50s, they abated a lot of cornfields to build our industrial tract. But when 353 was put in place, it was really meant to kind of redevelop downtowns, and we've just come around 70 plus years later, and now we're kind of really using 353. But we also have an industrial development authority, and so there could be funds available in those places. So we be aware of those. Also check at your county level. So like I live in Franklin County here in Missouri, and their economic development commission actually has a low interest loan program for building renovation and for businesses. And so that's something you want to be available to, is check every level of government and see what opportunities there are. Of course, there's the state level with Department of Economic Development and the State Historic Preservation Office, and then the federal level, understanding. So I wanted to talk to you as nonprofits doing work as well as private property owners. So I'll try and identify when it can be used privately or it really needs to be used as a nonprofit or publicly. But of course, the National Park Service has the tax credit programs. EDA has some opportunities. Now that's a pretty significant level of writing. That's kind of the stuff that even Missouri Main Street is doing. But that's another place you need to look for a partnership. The nicest thing about being a part of an organization like Missouri Main Street is that peer-to-peer contact, where you can be like, oh, we're trying to do this, and they can be like, oh, you know what, I heard about this town in Iowa and they did it this way, or I heard about, did you see what, Excelsior Springs was doing, and they did some layering funding this way. So the best thing about Missouri Main Street is you showing up and attending and talking to people, and it might not be relevant to you in the moment, but maybe a week or a year down the line, it could be relevant. There's community development block grants that are potentially available, more public use, but could be used privately. They have the new downtown revitalization program that I know Missouri Main Street would be happy to work with the community on, where you pick a group of buildings for some renovation. There's the HUD's Hope 6 Main Street funding. They award once a year if the program is funded, and that's a complete renovation of a building. And then formerly, we used to see a lot of like sustainability funding, and that's something to be aware of, when you go, if that comes back in the future. So again, being involved with Main Street, they'll help you understand, are there community foundations? Are there other funds? Some fun things as a Main Street program that you could potentially put together. The revolving loan funds, you can see lots of examples of those. I know when we did ours in Washington, we copied what Clinton, Missouri was doing, and Chillicothe, Missouri already had really great revolving loan programs. Bulk pricing. This is something I always wanted to do, but we're a red brick community, lots of red brick all over, and so tuck pointing is huge for us. And so one of the things we had always talked about doing was, if there are 3 buildings in a block that all need the tuck pointing, when they bring the scaffolding in, just paying to bring the scaffolding in is crazy. So if you're able to do like 3 neighboring buildings or 4 neighboring buildings at one time, you could potentially, through the Main Street program or the group of property owners, negotiate that. Like, you're going to be able to do 4 different projects at one time. And so maybe you can get like a bulk pricing. It made me think of this because we did do this with our Christmas lights. We paid one electric company to come in and do our electrical, do the lights, set them up, make sure they were, replace all the bulbs, and then we just assessed it per building. So that's kind of some of the fun things that the Main Street program can do, is put those groups together and potentially get you better pricing. Of course, we've talked about the other 3 that I listed there. The Missouri Main Street Connection had the Paul Brune opportunity, which was just, it blew me away. I really wish that that was available when I was around. But that was, I think, up to $50,000 per property. I know there are a lot of roofs and some windows and tuck pointing that happened, but there's hopes to do that again in the future, and so you really need to stay connected and involved. And when they say that we have, National Park Service Paul Brune grants available again, you need to work with your Main Street organization and apply for those funds. There are some historic preservation fund grants at the state level through the State Historic Preservation Office. And I put the Missouri Arts Council on here because if you do have an arts council or someone heavily involved in the arts, they will sometimes do capital improvement funds for that art area. These are all very specific, and I'm glossing over them quickly just so that you're aware of them, but you can do some more in-depth research. At the national level, of course, we have the National Trust for Historic Preservation. There's the Joanna Favrot Fund, the Hart Small Towns Fund, the Woods Mitchell, I think, is an interior fund. There's a new Route 66 fund. Small Restaurants Fund, and of course the Sacred Places. So think of churches. Well, I'm actually looking into the Sacred Places now because I'm curious if they're gonna, and I don't know the answer, if they would fund a renovation of a church that's no longer used as a church. It's an adaptive reuse into a local historical society. So that's really fun. Main Street America will let you know about different things. Of course, there's the T-Mobile grant. So in the past, there's been some American Express grants. I think there's 2 communities in Missouri that got the T-Mobile grant. I know Washington's one of them, and they tuck pointed a building on Main Street with the $50,000 that they received. So talking about combining things, layering this funding so that it makes sense, leveraging your public and private partnerships, and every project's funding stack looks different. So and when you apply a grant, the odds of you getting it are so rare, but sometimes it does happen, and putting all of this together does take time. So some pitfalls and pro tips: start early, way early. Funding takes a lot of time. You have to keep the detailed records and photos. You must hire experienced professionals to get through, especially the historic preservation tax credits. You want to stay in close contact with your state historic preservation office on those, but also your Main Street organization. Expect delays and plan for them. Getting started, so you want to, obviously what we talked about this whole thing was assess your property's condition, eligibility, build your team, identify your funding stack, connect across the board. So key takeaways for you to take away today: preservation is mission driven and financially smart. Missouri does offer some powerful tools for you, and especially partnerships. Success requires planning, patience, and teamwork. And every project strengthens your community's profile and brings attention to it. And really that notion of what is the neighbor doing and keeping up with the Joneses has been in full effect, at least in my home community, for the last 15 years, and we've seen tremendous reinvestment. So it really sometimes does just take one person to take that leap, and then you can see a lot of great reinvestment. So a specific plug for Missouri Main Street: they do have the Doctor is In consultation, and so if you're just curious and you want to know what a group of 5 or 6 people think about your building and the ideas for it, or how bad is the condition, what needs to be done, that's a great place to go to. It's free. It's something that you just fill out a form on the MMSC's website at momainstreet.org. They have a professional directory, so if you need that person that is experienced in tuck pointing and windows, folks like Dana and Joe are on there. And of course, the State Historic Preservation Office. The National Park Service does have the technical preservation services, and then of course the National Trust for Historic Preservation. So I tried to keep that quick. I hope that wasn't too quick.
Thanks, Bridgette. You skipped over the historic preservation one-pagers.
I did miss. I did write it.
Yes, you did. And there are some great resources. So we got this idea. The National Trust did these probably, 30 years ago. Mm-hmm. And we asked them if they were going to redo them or update them. And their answer was no, but if you guys do it, would you share copies with us? And so the Historic Preservation Committee within Missouri Main Street has been updating those. And I believe we have 4 or 5 completed. Yeah, and so those are on our website. I dropped one in the chat. Some people haven't been able to download it. If you're not, put your email in the chat and I will email it to you. Joe and Dana, come back to us, please. We've got a couple questions here. Bridgette, I'm going to start with you because this actually, I think, is a good commercial for The Doctor is In. James Leitner says that he bought a building in Chillicothe. It's an 1890s building. It's non-contributing. It had sheet metal facade put on it. It has since been removed. Wants to know what are his next steps. So, I mean, that there's so many parameters and questions related to that. This would be a great opportunity for James to get a consultation with the doctors on
Karen is who
his
I'm
project.
Thinking of.
Yeah.
So my first question is was it made non-contributing while it had the sheet metal facade on it? Because sometimes just
Right.
removing that would
Yeah.
make it contributing, but you
Yeah.
have to do the re-eligibility with SHPO.
Right. Yep. Yep. So James says yes, but I think there's just so many questions that you guys would need to know to answer his questions or help him with his next step. So James, I invite you to go on our website, look for The Doctor Is In under our programs. It's a quick, simple application, and you'll get consultations. Dana is one of those, as far as on being the HP committee, and also Karen Bodie Baxter, who is a historic preservation consultant, Dr. Stephen Hoffman that Bridgette mentioned, just great folks on that committee that can help you kind of put together your plan for that. So that's the perfect thing that we're there to help you with. And so I encourage you to do that, James. I have a question for whoever wants to answer it. How can you determine whether a building qualifies as historic under federal, state, and local criteria? If a building isn't currently designated as such, is it reasonable or feasible of getting it recognized as historic? Who wants to take that?
Kind of need more information. Yeah.
The state SHPO is a great resource. Their website will walk you through that.
So that's Kindle. That's the State Historic Preservation Office has some great guidelines. And yes, James, our website is momainstreet.org. Yes.
And I mean, it's a shameless plug for Karen Baxter Bodie, but she's a great resource as well.
Right,
Yeah.
right. So yeah, I mean, there's lots of questions. Local designation is very different than state designation, which is very different than federal designation. So there's different criteria and different things to follow there. But the place to start would be the State Historic Preservation Office. They're great folks and can help you with that. There's a question, probably Bridgette. Once a nonprofit has tax credits, how do they sell them? So I'm assuming they're doing a building or want to do a building and get the state historic tax credits for that. Is that allowed? And is Missouri letting nonprofits get tax credits? But is it now allowed at the federal level?
And I have to be honest, I am not an expert in tax credits. When they asked me to do this, I was like, I am not an expert in tax credits. So the nonprofits being able to utilize them, that's new. It's new to the point where I have not experienced it personally yet. And so I know if you're already kind of in that process, we can connect you with our partners at U.S. Bank. We have a board member, Robert Espelin, who could direct us to the appropriate person for your area of the state to talk about that. I don't know, Keith. That is a newer thing.
Our board president, Chris Johnson, is on our call on the webinar. Chris, if you have any knowledge with that, if you might type that into the chat, that would be great, and I'll share that.
It's new.
Yeah,
So,
very new. Yep.
And I believe it's only for rural communities, so population size comes into effect.
Okay. Yeah, we don't make anything easy, right? So, Joe, how do you feel about using masonry consolidation spray to firm up brick, but not to seal it?
Yeah, great topic. So,
First of all, explain what that is, because I don't know that I know exactly what it is.
Sure. So basically, there's various manufacturers out there. One manufacturer, Prosoco, probably butchering the name. There's an H100 product that might be okay. There's probably other similar products as well. But the idea is that it's helping reduce initial water infiltration to soak into the brick assembly, but still is porous and will actually allow for good vapor permeability.
Okay.
If you're going to use a product such as that, you need to make sure it's vapor permeable because, once again, those older brick systems have to be able to breathe and dry outward. So we don't want to trap the moisture in. So places where I think that would be applicable is, for example, if you had, let's say, a storefront row, a whole bunch of buildings, and one came down in between, so you create sort of a vacant lot between, then you have really that soft brick exposed.
Happens many times. Yep.
If you don't do anything with that, a lot of times you'll start seeing the brick deterioration over time.
Right.
So in applications such as that, some people go with a stucco, which I'm not advising, but others will consider this type of treatment. I think that would be a good opportunity for this type of treatment. But just
Okay.
proactively on a surface of a wall system, you might want to talk to your trusted mason. I would use that as my plan A.
Okay. And then, Joe, related to that, there was a question about how do you feel about murals on the sides of buildings?
I think they look great. But if you do have a mural on the side of the building, the right approach, which almost never would happen, would be to use a vapor permeable paint, but it's quite a bit more expensive. Um, just give the building ability to dry out. So if you can't let it dry out on the exterior, make sure at least the interior side of that wall, you have the ability to dry out. So avoid trying to put like fiberglass, bad insulation in there, a membrane. You really want to, at least if you're in an HVAC system, to dry it out inward instead of outward if you're going to do that.
Okay. Okay. We are running out of time, and I appreciate everybody for hanging around. But I have one last question because this is something that does come up quite a bit. Is there assistance in making historic buildings accessible?
Financial.
I believe so, yes.
If it's doesn't, it's hard because the tax credits want you to keep the character defining. Yeah.
We modify buildings all the time to make them accessible. Most of the work we do requires that. So certainly if it's part of the construction of the existing building and it's not part of a new addition, it would be eligible for the credit. But in terms, the question may be referencing a specific funding for making buildings accessible, and I'm not familiar with anything specific to funding for improved accessibility.
So there is, Jim Thompson from Iowa talks about this, and so I'm searching it real quick.
I found it.
There is
It's
a disabled access credit, Internal Revenue Code Section 44. It is a tax credit designed for small businesses that incur cost for accessibility improvements.
it's
So
about
there is,
50%.
yeah, there is a tax credit. Yep. So just search that out or ask your tax professional. It's not well known, which is why Iowa's really been talking about it a lot.
It's
So
meant for small. I think in the building you have to have 30 or less employees. It's been around a long
yes,
time.
yep.
We've heard about it
Total
before.
revenue of $1 million or less, 30 or fewer
Yeah,
employees.
something like that.
Applies to expenses between $250 and $10,000. The maximum annual credit is $5,000. It's annual. So Jim talks about if you need to make bathrooms accessible, do one in one tax year, do the other one in the other tax year, so you can get the credit for both years. So you can make improvements annually and get that credit. So, all right. Well, I appreciate Joe. Welcome to the team. We appreciate you being here, and it was very fascinating. Dana and Bridgette, thank you as always for being a part of our board and the HP committee. And we want to thank everybody out there. And if you have any questions, I know there were lots of comments coming in at the end, but we do have to end. You can certainly email me and I can send that out. There are also some folks having problems downloading some of the stuff that we shared in the chat. Those of you that put your emails in there, I will send that to you. And then you'll get a copy of the recording link in a day or so after this is processed, and you can catch up on maybe some of the things that you missed. So thank you all very much, and have a great rest of your day. Thank you. Bye-bye.
Thank you.
Bye.